Hello, hello, ladies and gentlemen. All right, welcome back and welcome to our new unit on graphing. All right. Side note, I'm going to make a lot of really bad, maybe really bad, artsy jokes. But anyway, the point is this is as artsy as Mrs. Fry gets. So today, we're going to introduce the first topic in our unit, which is graphing the sine function. And as we do this, I'm also going to introduce some vocabulary to you and some different steps that we need in order to be successful with our graphs, okay? So the first thing I want to let you know is that I understand that traditionally when we graph on an X and a Y coordinate grid, okay? And so it's important for you to understand that in this unit, we aren't going to have that same X and Y axis, where we are still going to have a horizontal and a vertical axis. However, when we take our coordinates for this unit, we're going to use those from the unit circle. And so when we're graphing sine, what we're actually going to have is we're going to have a horizontal axis with theta, so our angles, and our y-axis will still have our y values at each of the different angles. So it's like we're picking one part of the unit circle's ordered pairs, and we're graphing that, okay? So we're going to take a look at the parent function for sine right now, okay? So this is very important. Whenever we're talking about a parent function, we're talking about the general shape for every single graph. And so it's very important to have this shape firmly in your head as we begin to graph all sorts of different transformed sine functions. Now you should notice that we've provided you with a grid, okay? But that grid doesn't have a horizontal or vertical axis because depending on everything else going on in the problem, you may need to shift where you draw that. But for right now, I'm going to draw my horizontal axis directly across, and I'm going to draw a vertical axis over here. I'm going to kind of mix it up depending on the problem just to give you some variety. And I want you to remember that the horizontal axis is theta, that's angles, and the vertical axis is going to be y values. All right? So to start this out, I just want you to kind of think about the unit circle. All right? And I want you to think about traveling around and all those different values because we've got, you know, a half or 1 or root 3 over 2 and root 2 over 2. There are some nice values to graph, and then there are some not so nice values. So if we start off here on the right-hand side at the place where we'd start making our rotations, that would be at 0, as in 0 radians, okay? And the sine value at that location is also 0. Okay, we're just worrying about that y coordinate. So we'd plot a point at the origin. And then if you think about it, everything inside the quadrant is a fraction or a decimal. So the next place that I'm going to stop is at pi over 2. All right? And at pi over 2, that ordered pair is 0, 1. So it means the y value is 1. Okay, so I'm going to have a height of 1. And then if I keep going, I'm back at pi, and I have a height of 0 because that ordered pair is -1, 0. And then if I continue around my circle, I'm at 0, -1. So then I'm going down to -1, and then if I come back to this spot right here, 2 pi, I'm back at 0. So if you'll notice, and I'm going to make these a little bit thicker. We've got these 5 different points making our curve, okay? And so what ends up happening is we get this shape. And the cool thing about sine is that because you can keep going around and around and around the circle, you can keep going and repeat that pattern over and over again. This would be, let's see, 5 pi over 2, and 3 pi, and 7 pi over 2, and 4 pi. And we would go up 1 from this origin, this horizontal axis, down back on that axis, below and above. And if you can kind of remember that pattern, that you're going up 1, back to the middle, down 1, then you're going to really remember that. Each time you cycle through that, that's called a period. okay? That's your cycle through the graph, okay? And the length of that from start to finish of the period is 2 pi for our parent function, okay? So if you notice, that distance is 2 pi, and then if you go from 2 to 4, that's also, 2 pi. The next characteristic we want to notice is this distance above that horizontal axis, all right? So this length right here, this height, is 1 unit, okay? And we call that our amplitude, all right? And it is the, I'm just going to write this in tiny letters. This is the height above or below the midline, all right? And I'll talk in a little bit about what the midline is, because the midline is not always on the horizontal axis. And so that is always positive, like it's an absolute value. So it's the height above or below your midline is your amplitude. Now, to get back to a few other characteristics before I wrap up some more vocabulary topics. If you look at this, I know that I stopped my graph here, but technically this graph is just going to keep going in both directions forever and ever and ever, okay? And it's going to keep bouncing between that height of 1 and this height below at -1, okay? So what that means is if it's going to keep going on forever positively and on forever negatively, our domain is -infinity to infinity, all right? And so that is, if you want to think about this, all thetas that are possible, right? All angles. You can spin around infinitely and find a sine value, right? The range of this function, if you want to look at that, is how low, right? So how low this graph goes until how high it is. Really, we're thinking about the peaks and the valleys here. And so our range of this graph goes from -1 until +1. And because it stops at those places, we put our square brackets because there are points at those locations, okay? So -1 to 1. And that's going to change a little bit depending on your function. But these are all the characteristics of our parent function. A few other pieces of vocabulary. So as I said, the period of any trig graph is the horizontal distance or length, depending on which word maybe makes more sense to you, of one cycle, all right? And for sine or cosine, that length equals 2 pi, all right? And then the amplitude of any trig function is the absolute value of the height vertically, again, if that helps, above, below the midline. You could also remember that it's half of the range, in other words, half the distance of the range, or just remember that it's always positive. I guess you don't really need the or. It's not this or that. It's always positive. Okay? And then a couple of other things that you need to know related to transformations. Okay, so this is really more of a truth about being outside versus inside. Please remember that anything outside acts as you see it, and you want to handle in order of operations, okay? And then anything that's going on inside acts inverse to its appearance, okay? So if you think something's being added, it's really subtracted. If you think something's multiplying, it's really the reciprocal of that value. And remember that you have to reverse your order of operations in order to make sure you do that properly. And I'm going to go over that both in this video and also in our cosine video. Okay, so with that, let's take a look at a couple of graphs. So example number 1 is focusing on what happens when the amplitude changes. Okay, so if you don't really have anything else going on other than the amplitude changing, I'm generally going to keep my horizontal axis right in the middle. And for this one, I'm going to put my vertical axis in the middle just to mix things up for you a little bit, just to give some variety. So since we're not shifting off of anything, I'm going to start at 0, okay? And I'm going to notice, and for this graph, I'm going to draw in for you these 5 points, okay? That's the parent, okay? That is not the actual graph. I'm also going to notice that since there isn't anything else changing other than we're multiplying by 5, so that's why I know this is an amplitude change, that I'm going to use the same for additional scalars for my horizontal axis of theta, okay? And so that means my period is still going to be 2 pi, okay? But here's what's going to be different. If I think about each of these points, that 5 is like multiplying 5 times the y value, okay? So right here at 0, 5 times the height of 0 is still 0. But 5 times 1, well, that's 1, 2, 3, 4, 5. So I'm going to need to change that a little bit. So actually, I may go back. So sometimes you guys are going to have to do a little editing. I don't always put the parent function in here, but instead of 5 times 1, instead of a height of 1, it's going to be a height of 5, because 5 times 1 is 5. So 1, 2, 3, 4, 5. So you want to change the scale of your graph so that it goes up to 5. But 5 times 0 is still 0. And so the same thing's going to happen down here, right? We would normally be at -1, but instead we're going to go down to -1, 2, 3, 4, 5, because we're scaling this so that it's 5 times taller in both directions. Okay, so now my graph's going to go way up and come way down and come back. Okay? So that's only one cycle, okay? So I'm going to work my way backwards, going down 5, back, up 5, and back down to create a second period of my function. And I also want to point out that you really want to make sure you hit the point and that you make it a curve, right? Think about it as a parabola and then another parabola, all right? I don't want to see any, graphs that look like triangles, okay? So our amplitude of this function is 5 because that's the absolute value of our first number right here, our amplitude. And then I also want to make sure I scale this graph correctly, so I'm going to basically write the same values but negative since my middle right there is 0. So now I've got my scale, I've got my period. The only thing left to do is write down my domain. My domain is -infinity to infinity because technically I could keep drawing this graph over and over and over again, but I didn't. My range, that's what really changed. Okay, so just so nobody gets too confizzled. My range is now this bottom value, -5, until this top value, 5. All right, with square brackets around it. We should have just enough time for me to talk about one more thing before you get into your practicing part of this activity. So the thing we need to address is the fact that the horizontal axis is going to change. So let me kind of fill in some of these things for you, and hopefully you can see this pattern. All right, so you have 4 equations, and I wrote the period for each of those below it. And I want you to notice that in this second one, we have 2 in there, which is like cutting something in half, right? Dividing by 3, because we've got 3 times inside. And here we've got multiplying by 4. So if you notice, what happened was each of the period functions changed when there was a number inside. Basically, that number is called our b value. And so to figure out your period, the general rule is you're going to take 2 pi and you're going to divide it by the b value, okay? And whenever that happens, you're going to need to change the scale of your horizontal axis a little bit. So I don't know if you realized it, but the scale of the graphs we were looking at for the parent function was pi over 2. And so if I have a period of pi, now that's going to be pi divided by 4. And so same thing, this is going to be 2 pi divided by. So we're going to get pi over 6 or 2 pi depending. So in general, you're going to have to take your period and divide it by 4 to scale.